So this is bus 1, this is bus 2, this is bus 3. And these are the values which are provided for the self impedances for this particular question. So this is the figure for us. So what is the question? Question is in this way. For the power system shown in figure, when a three-phase to ground fault occurs on bus 2, calculate the following. Okay. So number 1, what are to be calculated? Let us see. Number 1, short circuit current at bus 2. Number 2, fault voltages at bus 1 and bus 2. And number 3, short circuit current to phase B of the transformer. So this is the question which is asked to us. So we have already solved one problem related to this, where we have seen the formula for the short circuit current, and you can see here the type of fault which is given is three-phase to ground fault. So this is what is given here. So we have to consider this, and we have to solve the problem accordingly. So this is the problem available with us. Now what we require is in the solution we require ZBus 1. Why? Because in case of a three-phase fault, you know only the positive sequence component are available. The negative sequence component and the zero sequence component are not present. So we are interested only in the positive sequence component value. So when we solve this equation, when we solve this particular problem, I will just draw the graph here. As you can see here in this problem, we have 3 buses, right? So you can see here, this is bus number 1, bus number 2 and bus number 3. All the values are given. We are with the help of these values, we have to find the ZBus in this way: 1, 2, 3, and here also 1, 2, 3. So the ZBus that we will get will be a 3 by 3 bus. So what I will do here, I will write the values directly because we have to solve the problem. So you can solve this in your copies. You can take this as a homework and solve solve in your copies. Get the detailed steps. You all know what are the steps which is associated. First, we have to draw the graph. Then we have to identify branch and link, and then add one by one the elements. If it is a branch, use the formula for branch. If it is a link, use the formula for link, and then simultaneously complete all the steps and then find out the ZBus. So what I will do here, I will make the graph for you. With the help of this graph, you can solve the problem with the help of algorithm, because unless and until you get this ZBus, you will not be in a position to find out all this, right? So the first bit is to find the short circuit current. Second bit is to find the bus voltages. Third bit is to find the short circuit current through phase B of the transformer element. So all these points you will not be able to calculate if you don't have these values. So these values are to be found out. Once you are having all these values available with you, then you can apply the formula, and by applying the formula you can calculate the short circuit current, fault voltages at bus 1 and bus 2, as well as the short circuit current through phase B of the transformer element. But the thing is, first you have to find out the ZBus 1. How you will find the ZBus 1? For finding this ZBus 1, you will require to first draw the graph. So let me draw the graph here. You can take this. So there are 3 buses. I will make the 3 buses this way one by one. Bus number 1, bus number 2, bus number 3, and the reference bus, that is bus number 0. So in this way I have drawn all the buses. After drawing all the buses, I have to check the power system network. Here the generator is connected in bus number 1 only. So I have to connect bus number 1 with 0. So this will be bus number 1 with 0. I will give the direction also in this way. Then in the diagram we can see 1 is connected to 2 and 2 is connected to 3 2 times. So how I will connect? I will connect in this way: 1 with 2 and then 2 with 3 2 times in this way. Then I will number the elements 1, 2, 3 and 4. So there will be 4 elements here. You have to add all these elements using the algorithm technique which we have already learned in unit number 2, and start the problem. But before that, we will require here the total number of elements, nodes, branch and link. All these 3 we will require, then we can start the things. So total number of elements is 4, nodes is also 4, so branch will be 4 minus 1, that is 3, and link will be 4 minus 3, that is 1. So in this way we have to identify which will be branch and which will be link. So it's very simple here. So we can consider the last element, that is the 4th element, as link, because or if we consider 1, 2, 3 as branches, then we have only the link, that is 4 available with us. So this we can consider as link. So this we will draw with the dotted line. So in this way, what we in this way we can have the system in this way. So this will be our link. So I will draw it with the dotted line. So in this way we have drawn the link, that is 1, 2, 3 and 4. Now we have to write the values of the self impedances that is given in the numerical. So we will see from generator to 1 the value is 0.23. So we will put here 0.23 because we will require all these values to solve the problem. Then 1 to 2 it is 0.25. So I will write here 0.25. Okay. Then 2 to 3 there is two transmission line. Both the transmission lines are having the self impedances of 0.42 as well as 0.42. So I will write this in this way, and this will complete my graph. So once my graph is completed, then we can start with the algorithm technique. We have the algorithm technique available with us, and with the help of this algorithm technique we can start adding the elements one by one. First element we can write add element 1, which is a branch, then add element 2 again, which is a branch, add element 3 again, which is a branch, add element 4. So now 4 will be linked. So when you will apply the formula for link, then you have to first add the link and then modify the ZBus as we have done in the unit number 2. So the same procedure you will follow here, and one by one you will add the elements and complete the ZBus. So I will give the solution of the ZBus because we will require this solution here to solve the problem. So I will write the solution. Please note it down. This is a homework for all of you. You have to do it in your copies. I am just giving directly the results. So this is the result. That is, we get the ZBus in this way: 0.23J, 0.23J. Just a minute. J will not be applicable here because we don't have the values here are given. Let us yes, one statement we have missed out here. So please write it in the question that here you have to write one line: the positive sequence reactance in per unit. So all these values that are given, they are in reactances. Okay. So you have to apply J with them. Reactances in per unit are given. So that's why our answer will also come in the reactances. Okay. So this is the change. So I will write the answers directly here. So the answer is in this way. The first row is 0.23J, 0.23J, again 0.23J. Then second row is 0.23J, then 0.48J, then again 0.48J, then 0.23J, 0.48J, and last value is 0.69J. So this is the result when you will calculate the ZBus using the algorithm technique. You will get the ZBus in this way. So with the help of this ZBus, I hope you all will be able to find out the values of the fault current. One more thing which is given here in this problem is ZF value is given as 0.32 per unit. So please note one more given: ZF value is given as 0.32 per unit. Okay. So with this we are ready to solve this numerical, because for ZBus for fault current we require the ZBus, and ZBus we have identified. I have given the solution for the ZBus. Now let us start with the bits one by one. The first bit is to calculate the fault current. So fault location, where is the fault location? Fault location is bus number 2, right? In the question, if you will read the question properly, you will see that the fault location that is given here in this case is bus number 2. So fault bus is equal to 2. So therefore, with this, what we have is I21 is equal to V20 upon Z221 plus ZF. So this is the formula that we have with us, where V2 of 0 is the pre-fault voltage, which we always take as 1 at an angle 0, right? So 1 at an angle 0 degree upon Z22. What is Z22? If you will refer to your ZBus, you will see that Z22 is 0.48J plus ZF. ZF is given as 0.32. So in this way, you will get the I21. So calculate it and reply in the chat box what is the value of I21. Then once you get the value of I21, you have to find out I2ABC. What will be I2ABC? I2ABC will be equal to 1, 1, 1, 1 alpha square alpha, 1 alpha alpha square multiplied by I20, I21 and I22. So we will get the result of our I2ABC from here. So what is the value of I21? Please reply on the chat box. What is the calculation of the I21? Okay, so 1.733 at an angle minus 56.30. So I will write here 1.7334 at an angle minus 56.30 degree. Of course, the unit will be per unit. Don't forget to write the unit, because here we cannot write ampere. Why we cannot write the ampere? Because we know that all the values that we have considered here is in terms of the per unit term, right? So we cannot write here directly ampere. So all these are in per unit system, so we cannot write this values in terms of the ampere. Next, calculate this and reply what is the value of I20. You know I20 is 0, so I will write here the simplified form. Then reply me the final answer. So here it will be 0, then here it will be 1.7334 at an angle minus 56.30 and 0. So reply me the final answer. What is the final answer? Okay. So reply me here what will be the final answer. I2ABC. First row, if anyone have calculated, reply here. If anyone have calculated, please reply here. What is the answer? First one. First answer will be obviously the same, that is 1.7334 at an angle minus 56.30 degree. What will be the second one? Magnitude will be same, of course, only there will be variation in the angle. So there will be only the variation of angle because see this is a symmetrical fault. हमें पता है symmetrical fault में क्या होता है? Symmetrical fault में magnitude same होता है but phase angle 120 से different होता है, right? So phase angle will be different. Angle is minus 176, Mayuri. You have written plus 126. So it's not plus 126, it is minus 176. Okay, please check it out. Okay, so minus 176.30 and the third one is 63.70. So how to cross check whether your answers which you are getting is correct or not? So the cross check point is that you should get the same magnitude every time. Why? Because this is a symmetrical fault, and in case of a symmetrical fault we know that the magnitude is same and the phase shift is the phase difference between the A, B, C is 120 degree each. Okay, so you can see very well that there is a phase shift of 120 degree between A and B as well as a phase shift of 120 degree from B and C. So this means that whatever calculations we have done, these calculations are correct. Next, they have asked us the bus voltages. So bus voltages, also you all know what is the formula. So bus voltages they have specifically asked at bus number 1 and 2. So what about 2? 2 is the bus where fault has occurred. So naturally in the bus 2, the voltages will be 0. So there is no need of calculating it. But for bus number 1, we need to calculate. So let us calculate this, and we know that only positive sequence component is present. So we will write here in this way 1 minus Z I K. I is 2 and 1 and K is 2. Z1 to 1, I to 1. So this will be 1 minus Z12. What is Z12? Z12, if you will check in the ZBus, it is 0.23J multiplied by I21, which you have just now calculated. So this is minus 56.30. So in this way you will get the value of V11. So please reply what is the value of V11. Then we with the help of this we will calculate. Therefore V1 ABC is equal to 1 alpha square alpha 1 alpha alpha square multiplied by V10 V11 V12, where this 0 1 2 are zero sequence, positive sequence and negative sequence. So out of this there will be only positive sequence available. The negative sequence and zero sequence will not be available. So in place of that we will simply put 0. So we will put 0 here and 0 here. Only we will have V11. So can anyone reply what is the value of V11 if anyone has calculated? So we will write it here. What is V11? Yes, anyone please reply fast. V11. Please reply fast. 1 minus 0.23J multiplied by 1.7334 at an angle minus 56.30 degree. That is equal to, what is the value? Okay, 0.7039 at an angle minus 18.31 degree per unit. Very good. So in this way we have got V1. So we will substitute here value of V1 0.7039 at an angle minus 18.31 degree, and from here we will get V1 ABC. So of course the first term will be the same, that is 0.7039 at an angle minus 18.31 degree. Then second term will be same magnitude, but there will be change in the angle. So the change in the angle is minus 138.31 degree, and third one is 7039 at an angle 101.69 degree. So please cross check this whatever I have written. So in this way, cross check it and reply whether the things that I have written is correct or not. And V2 ABC will be equal to 0. What is the reason? Reason is fault bus is equal to 2. So fault bus is equal to 2. That's why V2 ABC will be 0. All the three phases in the second bus will be having equal to 0. Similarly, we have the third term. What is the third bit that is asked in the question? Let us see the question once again. So third bit, what they have asked is short circuit current through the phase B of transformer, of the transformer element. So just let us see where the transformer is connected. So the transformer is connected between 1 and 2. That means we have to calculate I12. Okay. So we have to calculate I12 ABC, and from this we will know what is the value of the B phase of this I12. So for this again we will require I121. So I121 is equal to V11 minus V21 upon Z121. This is the formula. So V11 we have just now calculated 0.7039 at an angle minus 18.31 degree, minus C V2 everything will be 0. So I will write here 0. V2 is 0, so it will be 0. Then Z12, what is the value of Z12? It is 0.23 J. So from here I will get I121. So once I get I121, it is easy for us. So it is easy for us to calculate the still I think we should calculate this, at least V21 we should calculate. So V21 will be equal to 1 minus Z121 I21. So this will be 1 minus Z121 is 0.23 J multiplied by 0.7. No, this is I. So we require the value of I. Let us check what we have calculated the value of I. I is 1.7334 at an angle minus 56.30. 1.7334 at an angle minus 56.30. So एक बार चेक करके बताओ मुझे ये इसका आंसर क्या आता है V21, इसका आंसर क्या आता है एक बार चेक करके बताओ मुझे। V21 इज इक्वल टू फॉर्मूला के हिसाब से ये आना चाहिए। तो यहाँ क्या आंसर आ रहा है वो बताओ। इफ नॉन जीरो टर्म इज कमिंग देन वी हैव टू कंसिडर इट। जीरो अगर आ रहा है देन इट्स ओके, बट इफ इट्स नॉट जीरो वी हैव टू कंसिडर इट। सो प्लीज कैलकुलेट दिस फास्ट। ये वाला टर्म फटाफट कैलकुलेट करो और बताओ कितना आंसर आ रहा है। सो देन वी विल राइट I12 ABC is equal to 111 1 alpha square alpha 1 alpha alpha square multiplied by I120 I121 और I122। सो यहाँ से हमें पता है कि जीरो और नेगेटिव सीक्वेंस जीरो है, So we will write here in this way 1 1 1 1 alpha square alpha 1 alpha alpha square, और यहाँ पे जीरो सीक्वेंस जीरो रहेगा, नेगेटिव सीक्वेंस जीरो रहेगा, ओनली पॉजिटिव सीक्वेंस का टर्म हमें लिखना है. सो हैज एनीवन कैलकुलेटेड ये वाला टर्म कितना आ रहा है? दिस वन 1 minus Z121 I21. So 121 is 0.23J multiplied by 1.7334.
वो खाई तो देते.
अनुजा,
खाली उतनी रोटी.
ओके. सो हैज एनी कैलकुलेटेड, किसी ने कैलकुलेट किया है? V21 क्या आ रहा है? V21 प्लीज रिप्लाई फास्ट. V21 V21 का वैल्यू 0.8647 आ रहा है. Is it? Rest of the student please reply whether this value is coming or not. Okay, so let us write here 0.864 at an angle. यहाँ लिख रहा हूँ मैं ऊपर, देखो यहाँ जगह नहीं है, so I am writing above minus 6.213 डिग्री अपॉन 0.23J. अब I21 निकालो, क्या आ रहा है बताओ? I21 के लिए फॉर्मूला क्या है? V11 माइनस V21 अपॉन Z121. तो यहाँ से हमें 0.7039 एट एन एंगल माइनस 18.31 माइनस 0.864 एट एन एंगल माइनस 6.213 ये मिलेगा, और अपॉन 0.23J करोगे तो I21 मिलेगा. बताओ I21 क्या आ रहा है? I121 I121 क्या आ रहा है? जल्दी जल्दी बताओ. बी कंपोनेंट निकालना है ना हमने. मेक इट फास्ट, फटाफट सॉल्व करने की आदत डालो. एग्जाम में सॉल्व करके फिर एमसीक्यूज लिखने हैं, अगर एमसीक्यू बेस्ड क्वेश्चन पेपर रहा तो. Yes, calculate it fast. Has anyone got the answer? किसी को मिला है आंसर? Okay, so 0.9975. Let me write here 0.9975 at an angle 123.79 degree per unit. So same, अब हमें I12 ABC निकालना है. तो I12 ABC में सेम वैल्यू हम यहाँ पे पुट करेंगे 0.9975 at an angle 123.79 डिग्री, और फाइनली हम इसका आंसर निकालेंगे. तो इसके आंसर में सबसे पहले हमें क्या मिलेगा? 0.9975 एट एन एंगल 123.79 डिग्री. सेकंड 2 आएगा फिर 1.88. चेक करो, आंसर निकालो. इसका आंसर आपको मिलेगा, फिर ये चेंजेस मिलेगा आंसर में. तो देयर इज अ चेंज हियर. So what is the value of I121? I guess the value of I121 is 1.8837 at an angle minus 56.29 डिग्री पर यूनिट. सो ये आंसर आ रहा है, चेक कर लो सभी का. 1.8837 at an angle minus 56.29. ठीक है, दिस इज द आंसर ऑफ I121. सो प्लीज चेक इट. सो यहाँ पर भी चेंज हो जाएगा फिर. So there will be change here also. So let us see what is the change here. So this is 1.8837 at an angle minus 56.29 degree, right? So क्रॉस चेक करो एक बार, बाकी स्टूडेंट्स रिप्लाई करो क्रॉस चेक करके, I12 का वैल्यू जो मैंने यहाँ लिखा है इज इट करेक्ट और नॉट। सॉल्व करोगे तो आएंगे आंसर्स, तभी समझ में आएगा कि कहाँ गलत हो रहा है। सो थोड़ी देर पहले हमारे गलत हो गए थे तो हमने उसे चेंजेस करके सही कर लिया। सो नाउ द आंसर इज 1.8837 एट एन एंगल माइनस 56.29 डिग्री, और उसके बाद दूसरा आंसर है 1.8837 एट एन एंगल माइनस 176.29 डिग्री, और तीसरा आंसर है 1.8837 at an angle 63.71 degree, and of course the answers are in per unit. So please check it whether the answers are correct or not. अब हमें क्या पूछा हुआ है, हमें ट्रांसफॉर्मर एलिमेंट का बी फेज में क्या है वो पूछा है। ट्रांसफॉर्मर करंट इन बी फेज, तो बी फेज में कौन सा करंट होगा बताओ मुझे। दिस इज रिलेटेड टू ए, दिस इज रिलेटेड टू बी एंड दिस इज रिलेटेड टू सी। सो क्या लिखूं मैं यहाँ पर 1.8837 एट एन एंगल माइनस 176.29 डिग्री पर यूनिट। Okay, so in this way we have calculated our third bit. So this is the answer for third bit.